Hello, our most valued student. My name is Confident. Welcome to our second session where I am continuing to look at the April 2021 exam. And in this part, I'm continuing to look at question number 2. If you followed from the previous lesson, you will notice that I did the first 3 questions of question number 2. So in this particular section, I'm looking now at, if I can just make this clear, I did the first, as I said, I did the first questions, the first 3 questions. And in this part, I'm going to be looking at the last 2 questions, which is question 2.4 and question 2.5, and each question was worth 4 marks because there are 5 questions. So now let us quickly look at question 2.4. Now if you haven't seen the last 3 questions, I will encourage you just to check the channel and you'll find the solutions for the last 3 questions. So I'm just going to do this one quicker. It says 2.4, prove the following identity, and we are given that sec theta plus tan theta over cos theta is equal to 1 over 1 minus sin theta. So if I can write this fresh, so what we have is sec theta plus tan theta over cos theta it says we must prove that this is equal to 1 over 1 minus sin theta. Alright, so now I'm going to choose, in this case, I'm going to choose my left hand side. Now my left hand side is sec theta plus tan theta over cos theta. This is equal to, remember, sec is 1 over cos, plus, now if I can simplify, use the identity for tan, it will be sin theta over cos theta. Remember, that is 10. All this is divided by cos theta. And if I continue with that, it will be, now the common denominator here on this is a fraction, the common denominator on this part, the common denominator there is cos theta. So I will have, in this case, cos theta, and then on top it will be 1 plus sin theta, and this is divided by cos theta, which is that. Now if I continue, this is still equal to it's 1 plus sin theta over cos theta. I can use now this division sign to represent that division sign there, so divided by cos theta, so that I can convert this. Remember, now this is cos theta over 1, so that I can convert it as 1 plus sin theta over cos theta, from division to multiplication, which is 1 over cos theta. Remember, when you're changing from division to multiplication, you invert, is an inverse. Therefore, this continues to give me 1 plus sin theta over, now when you multiply cos theta times cos theta, it will be cos squared theta. Now at this stage, I'm going to use then the identity, which is cos squared theta plus sin squared theta is equal to 1. Now if you see cos squared theta, I will take sin squared on the other side. It will be cos squared theta is equal to 1 minus sin squared theta. Alright, so this is the way I'm going to write it, which is equal to 1 plus sine theta all over, and then I'm going to write it as 1 minus sine squared theta, and this is equal to, if you remember, this is a difference of two squares, the bottom one, which is 1 plus sine theta over the difference of two squares there. It is 1 minus sine theta and 1 plus sine theta, and then when you do that, you are able now to cancel the 1 plus sine theta, 1 plus sine theta, and this is equal to 1 over, because there is 1 on top there, 1 minus sine theta. And if you check now, it's 1 over 1 minus sine theta, which is what we are given as the proof there. So this then is my right hand side. So we've managed to prove that this simplifies to the right hand side. So basically this is what you are supposed to do to go about. Now let me have a look to see if ever it was possible to start from the right hand side. In this case, I think the simplest one was just to start from in this case, just to start from the left hand side, I think was more important. Let me not just complicate things here. So okay, that is how you could have solved that. Now let us look at the last question, 2.5 here. Now 2.5 says solve for alpha, and you're given sec alpha over 2 plus 5 degrees is equal to minus cos sec 20 degrees minus alpha, and they give you the region, they give you the value of alpha. It is between 0 degrees and 90 degrees. So if I do that, what I have here, they are saying alpha, sec, if I can write that, it is sec, and then I have here alpha over 2 plus 5 degrees. Now this is equal to minus cosec 20 minus alpha minus cosec 20 minus alpha. So now we are supposed to solve for alpha. Remember, they say 0 is less than or equal to alpha, which is less than or equal to 90 degrees. They gave us that condition. So if then I can solve for alpha here, so what I'm given is it's cosec. Remember, sec is 1 over cos alpha over 2 plus 5 degrees is equal to cosec is minus 1 over, and in this case it is sine 20 minus alpha. That is what I'm given. Now I just want to show you something here so that you can be able to solve this much quicker. If I have here is to do with cofunctions. So the cofunction, remember, if I have got cos 90 minus theta is equal to sine theta. So that is the cofunction. In this case, this will represent my theta now. So 20 minus alpha will represent my theta. So if I can write it, in that case, look at it, sine, it to be like this. Let me actually first rearrange it. It will be sine minus alpha plus 20 is equal to, now if I take out a negative, it will be sine, and then I take out a negative outside. Now if I take out a negative or I factorize a negative, it will be alpha minus 20 for that, like that. So I've got sine alpha minus 20, and at the same time I also use this part which says sine minus theta is equal to minus sine theta. I hope you're seeing that. So this particular negative and this represent the theta there. So now in that case it will be equal to minus sine alpha minus 20. So you see what I'm having. So here I can rewrite this statement as, here I can rewrite it now as equal to 1 over cos alpha over 2 plus 5. Actually is not equal to, put the arrow, because the equation, this is an equation, is equal to minus 1 over, so it's minus sine alpha minus 20. So now this helps me to get rid of this particular negative sign. You see, this and that now has cancelled. So now what I have is, I have got 1 over cos alpha over 2 plus 5 is equal to 1 over sin alpha minus 20. As I said, I'm going to use the cofunction there. So now how am I going to use it? Now this cofunction, the aim is to make, I want to make this into a cos. So is to convert that sine into a cos. So it means I'm going to say sine alpha minus 20 is equal to cos, remember the cofunction, and then you say 90 minus theta, and my theta is alpha minus 20. That is how you convert that to cofunction. So this will be 1 over cos alpha over 2 plus 5 is equal to 1 over, now I use the cofunction of sine, which is cos, but I subtract 90 from the angle, and the angle is alpha minus 20. I hope you're able to see that. So now I've managed to make cos, so now if I further simplify this, is because this is a fraction, the top is equal to the top, the bottom is equal to the bottom, or you can just cross multiply, but whatever case, therefore it means cos alpha over 2 plus 5, the bottom is, the denominator is equal to, since 1 is equal to 1, so the denominator is also equal to the denominator, which is cos 90 minus alpha minus 20. Now when you've done that, because you have got cos here, that's where the main thing lies. Because you have got cos here and you have got cos, you can just drop down the cos, and then it also therefore states that alpha over 2 plus 5 is equal to 90 minus alpha minus 20. That is actually what it means. So now when you open the bracket, you'll have alpha over 2 plus 5, in this case, is equal to 90 minus alpha plus 20, and then you have to solve for alpha now, simple algebra now that is employed. Take the alpha to the other side, you've got alpha over 2, it's alpha over 2 plus alpha is equal to 90 plus 20. Now the 5 joins there, it becomes negative 5. Now alpha over 2 plus alpha, I think it's 3 over 2 alpha there, because what you have is alpha over 2, which is 1 over 2 plus 3. Plus 1, which is 3 over 2. So I've got 3 over 2 alpha is equal to 90 plus 20 is equal to 110. So it's 90 plus 20 minus 5, which is, actually this is 90, not 9, which is 105. So this is 105. And then when you continue now to solve this, what I have here is you have to divide by 3 over 2, divide by 3 over 2. And then when you do that, our alpha is 105 divided by 3 over 2. So we have got 105 over 3 over 2. And then it gives me 70 degrees. So that is my value for alpha. So the question was here, remember, solve for alpha, and they said alpha is between 0 and 90 degrees, and you can see that my answer is 70 degrees, which means it is within the range. Now if I can test this answer where alpha is 70 degrees, come to the question here, and where there is alpha here, I put 70 degrees, and where there is alpha, I put 70 degrees. Now if I use the calculator on the first part, remember it's sec. Now the calculator cannot give me sec, is 1 over cos, so I say 1 over cos. That's how you have to enter your sec. But now it's alpha is 70 over 2 plus 5. So we have to find out what is my left hand side. You can see that my left hand side is giving me 1,305. So I've got 1,305 is equal to, I do the same thing, cosec. Remember, I can't enter cosec in the calculator, is 1 over sine, but it's not just 1 over sine, it's negative. In this case, it's negative 1 over sin. Now it's 20 minus 70 there. And then if I do that, it's 1,305. It's 1,305. Therefore, it means if it's balancing, therefore my answer here that I got for x is equal to 70, it becomes correct. So this is how you could have done to get, remember this question, I think it was worth 4 marks. And as I said, this is a continuation of the previous questions I did, the part 1, part 2 and part 3. You need to grab hold of the previous lessons, and then this is now a consolidation of the last 2 questions for 20 marks of that question. Now remember to subscribe to our channel if you have not subscribed, and you can also share the channel with some friends and colleagues. We have come to the end of our lesson. Join me again as I continue doing all the memorandum or some suggested solutions of this paper. Thank you.